Determine the left-sided limit and the right-sided limit and the two-sided limit as x approaches 0 of sine of x divided by 1 minus cosine of 2x. Each of these involves the limit as x approaches 0 of sine of x divided by 1 minus cosine of 2x. The first thing to do is try plugging a 0 in for each of the x's. That will give a sine of 0 divided by 1 minus cosine of 2 times 0. Sine of 0 is a 0 divided by 1 minus cosine of 2 times 0, which is 0, which gives 0 over 1 minus the cosine of 0 is a 1. So it is 0 over 1 minus 1, which is 0. We have the 0 over 0 indeterminate form. This will need to be reworked. One option is to make use of the three identities available for the cosine of 2x that is in the denominator here. Cosine of 2x equals 2 cosine squared x minus sine squared x, or 2 cosine squared x minus 1, or 1 minus 2 sine squared x. Since the numerator is a sine x, it's probably best to make use of the third option, 1 minus 2 sine squared x. So the limit of sine of x divided by 1 minus, and in place of cosine 2x, 1 minus 2 sine squared x. Which gives the limit as x approaches 0 of sine of x divided by 1, and distributing the minus sign through here will give a minus 1 and a plus 2 sine squared x. So the limit as x approaches 0 of sine of x divided by, the 1's can cancel, leaving 2 sine squared x. There's a sine of x in both the numerator and denominator that can cancel out. There's 2 of them in the denominator, so 1 will cancel, leaving 1 over in the denominator. The 1 in the numerator will cancel, leaving a 1 in the numerator. So this has now become limit as x approaches 0 of 1 over 2 sine x. We should no longer have the 0 over 0 indeterminate form now that we've canceled a sign out in the numerator and denominator, so we can try plugging a 0 in for the remaining x's, which will give 1 over 2 times the sine of 0. The sine of 0 is 0, so 1 over 2 times 0. 2 times 0 is 0, giving us 1 over 0. The 0 in the denominator is not actually a 0, since x is only approaching 0, it never reaches 0. But the limit result of a non-zero number over 0 equals to positive infinity or negative infinity, where the sign of the infinity often depends on the side the limit is approaching from. Therefore, we have to work out the one-sided limits separately. We have the left-sided limit indicated by the negative superscript on the 0. Sine of x divided by 1 minus cosine of 2x, the original. And we have the right-sided limit indicated by the positive superscript on the 0, also of the sine of x over 1 minus cosine of 2x, the original. Each of these can make use of the same identity. And so it will become sine of x divided by 1 minus 2 sine squared x, which will then become sine of x divided by 2 sine squared of x, and one of the sine x's can cancel from the denominator with the one that's in the numerator. And it reduces down to 1 over 2 sine of x. We want to see what's making 0 in the denominator here, which is the sine of x. As x approaches 0, sine of 0 is 0. It's approaching from the left side. The left side of 0 is a negative number. In the unit circle, this will be the negative first quadrant to be approaching 0, but yet be a negative angle. In the negative first quadrant, which is the equivalent quadrant as the fourth quadrant, except its negative angles in there, it will be a negative value for the sine. But sine is approaching 0 as x approaches 0, so we will replace sine of x with a negative 0. And then a 0 can be plugged in for all other x's. The result of this is 1 over 2 times sine is going to be replaced with a negative 0, since it will be a negative number the entire time, but approach to 0. There's no other x's to plug 0 into. This is the only result here, so we end up with a 1 over 2 times a negative 0 will be a negative 2 times 0 is 0. The numerator is a 1, which is a positive 1. A positive over a negative is a negative. Non-zero over 0 is an infinity. And there's the result of the left-sided limit. The right-sided limit will work out in a very similar fashion, making use of the identity. The ones cancel in the denominator. The sign from the numerator can cancel with one of the signs in the denominator. Giving 1 over 2 sine x. This time x is approaching from the right side. The right side of 0 is positive angles, but close to 0. This will be the first quadrant in the unit circle. And in the first quadrant of the unit circle, sine is positive. It's approaching to 0, and sine of 0 is 0, so it'll approach to a 0, but it will remain positive the entire time. So this will be able to be replaced with a positive 0, and then a 0 can be plugged in for any other x's. There is no other x's, so the result is 1 over 2 times a positive 0, which is 1 over 2 times a positive 0 will be a positive 2 times 0 is 0. The numerator is a positive 1. A positive over a positive is positive. Non-zero over 0 is infinity. And there's the result of the right-sided limit. The two-sided limit depends on the results of the one-sided limits. They do not match. The two-sided limit up here will therefore equal to does not exist. And there's the results of the three different limits.